Hello, so we're into the last part now in our series on how to skeletonise yourself with pose detection. If you haven't watched the first two videos already, I'd go back and do that because we learned how to start the webcam, how to draw on top of it, and then how to actually start doing the pose detection with TensorFlow.js. And now we're doing this final part, which is mapping an illustrated skeleton onto the pose. So before we start, let me just show you how we're going to be doing this. So here I've got a Figma of the little Halloween microsite that we made, and in here you can see we've got this skeleton illustration and we've split it up into all of the individual body parts. And what we've done is we then exported all of those as PNGs, and we're going to be individually drawing those into the right place over the top of the webcam feed. So let's just get rid of this for the moment. So the first thing I'm going to do is actually copy in those images into our projects. Create a new folder called assets, and then let's paste in the skeleton folder. There we go. So there's all of our body parts. The code for this whole tutorial is on GitHub, so you can use the same ones there, although it might be fun to experiment and use a different character instead and apply the same concepts. Okay, so we've got the body parts. And when we start to think about how you're going to map an image to the pose, there's a few things that we need. So the first thing is the position. So let's take the head for example. We need to know like the X and Y coordinates of where we're going to need to draw this image on the canvas. So that's easy. We just get given that basically with the key points that come back from the pose estimation. The second thing is the rotation of the image. So if I turn my head like this, we need to know to rotate the image that we're drawing in the same way. And then the last thing is sort of the vertical and horizontal scaling of the image. So if I turn my head to the side, we want the image to get smaller horizontally so that it still fits in the visible space on my head. And likewise, if it goes up and down, we want to make the vertical scaling adapt so that it fits on my head still as well. So one of those things we get given already, which is the coordinates. The other two we've got to calculate, and luckily we can do that using some fairly basic vector math. So what we're going to do is we're going to create a new helper file called vectors.ts. And I'm actually just going to paste this in again rather than typing it all out, but we'll go through what I put in there. So the first thing is we just create a little TypeScript interface for our vector. The vector in this, all we care about in this case is the X and Y. And then we've got a function called get middle, and that's going to just find the center point between two vectors. So in particular, we're going to be using that to find out the center point between the eyes. We've got get distance, which is just going to give you the pixel distance between two vectors. So we're going to be using that one to figure out the height of things, basically. So the distance between the center of the eyes and the mouth to sort of get a sense of scale for the head and the other body parts. And then get angle, and this is going to give us the angle in degrees between two vectors. All of these sort of algorithms, you can, if you don't understand this, it doesn't really matter if you don't understand this kind of stuff. It's just stuff you can Google. You know, if you just search find angle between two vectors, there's probably a Stack Overflow where this comes from. In fact, I'm pretty sure that's what I did to get this. Okay, so now that we've got that little vector helper file, if we go back to the skeleton class, which is going to be drawing our images, we can go and do a few things. So the first thing is we need to import one of our images. So let's just start with the head like we did here, and we'll do the other body parts later. Oops, didn't want to rename that. So let's import our head image, assets, skeleton head .png, and then we actually need to, we can't just use this imported image, we need to load it, and to do that you create a HTML image element. So we're going to do that now. I'm going to do new image, and then we can load it by setting the source on this. So source equals to head, like that. In a production app you'd want to wait for this to load. In our app it's probably not going to matter because other things are going to take longer to load than these images at the moment. So once we've done that, if we move down to this draw head function, and let's just delete this temporary debugging code that we've got at the moment, we'll leave in these key points because we still need those, and then we're going to define two new constants. So the first one is going to be called eye width, and I'm just going to put in 205 in there, and then the second one is eyes to mouth, and I'm going to put 220 in there. Now what these are the actual pixel distances between the eyes in this image. So it's about, what did I put, 205 pixels from the center of that eye to the center of that eye, and from the eyes down to this like mouth bit down here is 220-ish pixels. And the reason we've got those is because that's, we're going to be able to compare the distance in the pose between the eyes and the distance between the mouth to these real distances to calculate the scaling of the image when we draw it. So we'll come back to that in a sec. Next thing, let's just do a check to make sure that we've got all of these key points. Like that, and if we do, we're just going to return early to boot us out of this function and prevent us doing any of the other bit down here. So now we're going to be able to use our vector functions to do the math that we need to correctly position the image onto my head. So let's create a few more constants. The first one's going to be called eye angle degrees. And we're going to use the get angle helper function that we created. I should have imported that. Let's just move it up here. Like that. And we want to pass it the left eye and the right eye. The next one we want to do is get the distance between the left and right eyes. So we can use the get distance one. Pass it in the left eye again. Oops, screen left, I don't know where that came from. Left eye, right eye, not right mouth. That would cause some problems. And then finally, we can calculate our X, oh geez, what's happening to my typing? Our X scale, so the horizontal scale, by doing the distance divided by the eye width. So that's the distance in the pose divided by the distance in the image. Cool. So I just plugged my laptop in there. So we've got the X scale. Now the next thing we need to do is get the Y scale. So we need to do a bit more for that. So the first thing we're going to do is use the get middle helper to get the middle point between the left eye and right eye. And then we're going to do the same, but for the mouth. And then we're going to get the distance between those two new vectors. Like that. And then similarly to the x scale, we're going to do y scale equals to mouth like that. Cool. So at this point we've done all the maths we need to do to correctly position this. So let me just save that. Let me save this vectors file. And then the next thing we're going to do is actually draw the image. Now Canvas has got its own function called draw image, but we're going to create another helper function in here with the same name. And the reason we're going to do that is because we need to be able to do a few extra things that Canvas doesn't make that simple out of the box. Like we want to be able to rotate this image based on the angle that we've calculated up here, and we also want to be able to like offset it around an anchor point. So rather than if I just open up the head again, rather than it rotating around this top left point up here, we want to be able to tell it to rotate from like the center roughly, or where ideally wherever we're choosing the coordinate to place it from, so the sort of nose or something like that. So we're going to create a helper function that's going to allow us to do that. So it's going to be called draw image, and it's going to take an options object, which is going to have a few properties. The first one being image, and that's going to be the image you want to draw. The next one is going to be the x coordinate, y coordinate, height of the image, width of the image, misspelled that there, the rotation, an offset x, and an offset y. And then we're going to destructure that options object inside the function, so we've got a reference to all of them. Like that. And then we're going to use a few of the Canvas context API functions here. So the first one is save, and what that does is it sort of saves the state of the context as it is now, and we want to do that so that we can restore back to where we are now later. This isn't the most intuitive whenever you do this kind of thing, but hopefully it will make sense. So then the next thing we want to do is move the canvas to the coordinates that we're passing in here. So we can use the translate function to do that. And what that does is it sets the it resets the coordinates of the canvas so that 0, 0 when we're drawing now is actually whatever we've passed in here. So like say this was x was 200 and y was 200. It kind of resets the coordinate system to now be 0, 0, but at that position. The next step is to rotate the canvas. So we can use the rotate function to do that. And then we're going to do 180 plus rotation times math dot pi divided by 180. Now the 180s in this are because of the way that we've exported our images with them all sort of being going down like this way like that. This is basically just hard coding a rotation so that they're in the right angle as soon as they're drawn. And then other than that, we're passing in the actual degrees in addition to that to then rotate them further. And then finally, so now that after doing this, the canvas will be in the right place and it will be rotated how we want that image to be drawn, we can actually use the context draw image function to actually draw the image to the canvas. So let's go with width set x. So as I said, the canvas's coordinate system is now reset to sort of 0, 0. So 0 will actually be placing it wherever that x was. And then we do a bit of work here to basically offset it by the offset that we're passing in. So it's this bit of code here which is allowing us to actually sort of choose where on the x-axis we want the middle anchor point to be. And then over here the same for the y-axis, and then we just specify the width and height of the image. And then finally, after doing all of that, we want to reset the canvas back to what it was, the context. So we do context restore, and then this basically gets rid of all these rotations and translations and resets it to whatever it was back up here before we started, so that we can then do it again later. So now that we've got that function, let's go back up to our draw head one, and then let's actually make use of that. So we can go this dot draw image. We want to use the head that we've got. For the x coordinate, we want to use the nose key point x. For the y coordinate, we'll use this nose key point y. For the height, we can pass in our head image and get its actual height, and then times that by the y scale, and then do the same for the width, but using the x scale. And then the rotation, we're going to use that eye angle that we calculated up above. And for the offset x, we're going to do 0.55, and the offset y, we're going to do 0.8. Cool, so let's save that. Let's go back into main and turn on our render function and go and see if this is going to work. The suspense. Aha! There it is. So there you go. I've got a skull on my head now, and you can see as I move around it follows me. If I get closer to the camera, it gets bigger. I move further away, it gets smaller. As I turn left and right, you can see the sort of scaling of it. It kind of gives it a 3D effect as it gets smaller on my face as well. So now that we've got this, the only thing left to do really is use all of the code we've already written to draw all of the other body parts. So I'm actually going to do that now. I'm not going to make you sit through the pain of me typing that all out, because it ends up being quite a lot of functions. But let me just go and get them and paste them in. Just refresh it properly. So I've just pasted in these now, so you can now see in the draw function in our skeleton file, we've now got calls to all of these other functions, and they're all exactly the same as their head one, but with like some customized constants for like the length of the bits and that sort of thing. So you can see in that one there, that's the draw the lower right leg if it's in the shot, and so on. So hopefully any second. Aha, there you go. Look, you've got hands and everything, arms. You can see even with me doing all of this screen recording and stuff, it's still pretty responsive. There we go. How awesome is that? Da, 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 da. Cool, so that's everything really. Hopefully you found this fun. We've definitely enjoyed playing with this and had a great time making our little Halloween experience with it. I think there's a lot of real world possibilities for pose detection that are probably yet to be explored, but it's a really great way of learning by doing something fun like this. So yeah, if you enjoyed this video, let us know. If you've got any feedback, that'd be greatly appreciated as well. If you could like and subscribe, that'd be great, and then you know you'll have these kind of fun experiments delivered straight to you. We've got loads more ideas like this. But yeah, I hope you enjoy being a skeleton just in time for Halloween, and we'll see you later. Bye.